All right, for the rest of this chapter, we're going to be looking at what we call truth tables. So here in lesson 3, we're going to start working on truth tables. So that's all we really have left for the chapter for lessons 3 and 4. For those of you in honors geometry, this should look familiar to you. You took this, dealt with this back in honors geometry a long time ago. So here we go. When we create a truth table, we're going to be given some kind of a scenario like this. And our job is to figure out when this is true and when this is false. And ultimately, that's what we're going to discover right here in the very last column. But in order to get to the last column, you have to break down all the steps that lead you there. And so the way that every single one of these will start out is with a P and a Q scenario that you see right here. These will never change. So this is the way you always start these out. This represents every possible scenario that you could have. Either both of those statements are true, the first one is true and the second one is false. The first one is false and the second one is true, or they're both false. Those are the 4 scenarios that you could possibly come up with for the propositions of P and Q. And notice right here, again, this is what you have on your test, and so this is important that you know how to interpret this chart. So as you look at this, these are the 2 scenarios, and you can always start with these because these are the 2 possible cases that we can have. Imagine sort of a break right here within the chart, because the left side of this line are the 2 columns that you will always start with, but the right side of this line are the conclusions that we have to sort of figure out what goes where as we create our truth tables. So moving on. So we always start with those 2 right here. I always start with the individuals P and Q. From there, if you have any not statements, those need to get thrown in. So we have a not P and a not Q. And then at the end, we bring it all together, the not P or not Q. And so we're just going to need to go through row by row and fill out the T's and F's that go in there. So looking at proposition P, if this is not P, then just look at the rule for not P. Here's when P is true and false. Not P is simply the opposite of those, right? If P is true, then not P is false. And when P is false, not P is true. So if we're going to fill out our chart accordingly, if P is true, then not P is false. And whenever P is false, not P would be true. And the same is going to exist for not Q over here. One thing you'll notice on the table, there is no rule for not Q. So simply all we have to do for that is apply the not rule. This is the not rule that applies for any not scenario. And so generally we have to sort of generalize the rule and see this as anytime something is true, the not statement would be false. Anytime something is false, the not statement would say that it's true. So it doesn't matter if this is a P or a Q, we just have to be able to interpret the rule that we see from here to here. And so if we do that for the Q's, if Q is true, then not Q would be false. If Q is false, then not Q would be true. Again, true, false, and false, true. That's how we fill that out. And then so now for the very last one, and again, you notice this is the or statement right there. It's the what we call the disjunction. So that's this rule right here. You'll notice if you look at the heading, not P or not Q, students always ask me, well, where's the one for not P or not Q? Well, it's not going to be there. What you're going to see is the rule for any or scenario. And so we have to generalize this rule to apply for any or scenario. And so here's kind of how we have to interpret this rule. You'll notice anytime both statements are true, then the or rule is true. If the first part is true but the second part is false, so if anytime you read it as true, false, the rule says the overall statement is still true. If it goes false, true, still true. The only case this is false is when both statements are false. And that's the best way to generalize the rule for disjunction, is to come up with a general idea where it's always true except when they're both false. So you can see right here, if they're both false, then the whole thing is false. But in every other case, it's true. So over on our table here, we have to use that general idea. So again, anytime, the only time it's false is when they're both false. So right here, as I look from the responses from not P to the responses from not Q, so I'm looking that direction, so I'm going to go from not P to not Q. All right, that's the order that we're reading these in. As we said a second ago, anytime they are both false, the whole thing was false for this rule. That's the rule that we're focusing on right now. That's the only one where they were both false, so that's the only false I should have. These one is true false, so that's true. True true is true. So again, we always kind of looking to generalize the rule to use for these. So we're going to go through another one here. So in these last two scenarios, we're going to set up our own table instead of being given the outline. So again, I'm always going to start with P and Q. So PQ. From there, we always throw in any individual stuff. P and Q are the only individuals that we have up there. Beyond that, I would throw in any not columns, but there are no not statements up there. So from there, we go to any pairs, or parentheses. So in this case, I have a pair right here, P or Q. So that's got to be one of our column headings. That's the only pair that we see up there. So then we'd say, after we've used up all the pairs, we can then just use the overall statement, which is P or Q, then Q. So remember, P and Q always start the same way. You can always put these 8 values in to start your table. So these are the only 2 possible, or the only 4 possible scenarios you could ever have for these. So it's always going to be 4 rows, like we have right here. And then again, we're just looking now, so in the second one, this has the disjunction rule, or the OR rule. So if I find that rule on my table, there it is right there, I can simply model after what I see here. And remember how we generalize this. It's always true unless both statements are false. And that's just an easy way. That way you don't have to keep looking back and forth at your paper and the chart and your paper and the chart. Just generalize it, and then it fills these out really quickly. So it's always true unless they're both false. Then it's false. Right here in the last one, this is now the implication rule. This is our if-then phrasing right there. So if you look at the chart, find the rule, which is right here, and let's see if we can generalize this rule. So notice in this rule, it is always true except when the order reads true, false. So it's always true except for when the order reads true, false. And the order that we have to read it in is from here. So from these responses to these responses. So I have to go from P or Q to Q. So I'm going to read this from P or Q to Q. That's the order that we have to read it in. And again, because we generalize the rule, this is easy to fill these out pretty quickly. So again, the general statement on this is it's only false when the order reads true, false. So from here, I have true, 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 false, which is the only case we said it was false. And that's the only true, false case that we have. So everything else must be true. And that's just the easiest way, the quickest way to fill those out. Let's do one more right here. So again, I always want to start these out with the P and Q headings, the individual headings. I then want to throw in any not columns. So I have a not P in this, so that needs to make it in there. I don't have a not Q. So I then need to throw in any groups that I have. So I do have a not P and Q that needs to make it in there. I have a Q and P. And then I also need to finish it off with the overall statement that we're trying to solve. So there's all of it. And so now we just need to go on down the list, use our handy dandy chart over there to fill these out. So P and Q always start the same way, so we can fill those out first. All right, so again, for the knots, remember the rule is on that is simply anything that was true is now false, anything that was false is now true. So we always are looking to generalize that rule. So if it was true, now it's false. If it was false, now it's true. As far as not P and Q, the main thing that you got to see on this is we are just need to understand that I'm looking at the AND rule, the conjunction rule. So let's just generalize the conjunction rule. So if you look right here at the conjunction for P and Q, see if we can't generalize these results. You'll notice on this column right here, it's only true if both statements are true. And so that's a really easy generalization for that rule. So it's only true if both statements are true. So looking onto this, remember I have to read from left to right, from not P to Q. So I am interpreting it like this. So I'm looking at the not P response first, the Q response second. But this is an easy general rule because if it's only true when they're both true, let's just find those cases. Right here, they're both true, so it's true. Everything else must be false. And that's an easy way to generalize the rule. So the same would be true for Q and P. So in this case, for Q and P, I am looking from Q to P. So I'm doing this visually, looking from Q to P. So true, true, false, true, true, false, false, false. I'm just going in that order because that's the order that I see it here. But again, we generalize that statement as saying it's only true if they're both true. So just find those cases. So as I look right here, they're both true, and that's the only time that occurs. And we said it's only true if they're both true, so everything else must be false. All right, one more here. Last column. So the key on this last column is I'm going to read the responses from him to him. So because it's flowing this direction, that's the order I'm going to read those responses. So I'm going to go from those responses to those responses. Get that out of the way. So I'm going from those responses to those responses. So visually, this is what we're seeing right now, is from there to there. So as you look at our last column, remember the overall idea here is the disjunction rule or the OR rule. So if we generalize that rule, like we've already done, we can see that it's only true, that it's always true except for this case right here, and that's the case where both statements are false. So if they're both false, then it's false. So let's see if we can find any of those cases. So right here, they're both false. And right here, they're both false. And those are the only ones, which means the rest of them are true. Let me just close off with a couple quick ideas here. As you look at these charts, remember what the ending part is really all that matters, because this is what we were trying to figure out. We were trying to figure out in what scenarios is this statement true and in what scenarios is it false. And we now know when it's true and when it's false. A couple vocab words that you need to know, and this is important, this will be on our test. It is a tautology when the compound proposition is always true. This is the compound proposition, the last column. If you get all truths in the last column, then that's a special case called a tautology. It's a contradiction when it's all falses. So if you just look at the last column, if these were all false, then it's called a contradiction. We run into problems like this in the book where the wording is something along the lines of, point out the one scenario that had a compound proposition that was always false. So just remember what that's referring to. The compound proposition is the last column, and if it's all false, then we refer to that as a contradiction.